Welcome to Robominions.in AI interview preparation app. The topic of this video is queue using implementation of queue using array. So let's see how queue is implemented using array. So before starting the tracing of this code, I would request you to open this video on your laptop so that you have a bigger screen and you can clearly see the code and tracing of this code. And also I request you to download the app. Use the app Robominions.in AI interview preparation app. The app is available in the website Robominions.in. Okay, so this is the website. Click on download for latest version here. Let's start tracing the code implementing queue using array. So we have hash include stdi.h, hash include stdlib.h. Then we have struct queue underscore struct. Then we have the queue underscore struct has size of queue, front of queue, rear of queue, and queue underscore pointer, PTR pointer. Then we have enqueue, then we have dqueue, then we have int main. In int main we have queue underscore st. It is a type def rename of struct space queue underscore struct. So it's a rename of this structure. So you use and declare a new queue underscore dt structure and initialize the size of queue. So size is equal to 10, front of queue equal to -1, and rear of queue is again -1. Just a quick fix. So the size was just size, so we have renamed it while just recording this video. So size of queue equal to 10, so that is the initialization. Rear of queue equal to -1, front of queue equal to -1. Okay, then we have queue underscore pointer is null. So that queue underscore pointer which we access using dot operator, we access that pointer and allocate the 10 memory location. So we assign size of queue into integer type size. So size of queue is 10. So 10 memory locations will be assigned, but we are showing just one here. So first, whichever we are going to use, we will be showing only those because we don't have the space for the display here. So that is the reason it's not displayed. Then we have enqueue. Enqueue function is called. We will be enqueuing 10 data, and the address of the queue underscore dt structure is sent. So you will have access to these member variables and to this pointer. Okay, so enqueue. Then we have if rear of queue. So in the enqueue you receive queue underscore, so you receive the queue pointer. So queue pointer receives the address of queue underscore dt. So rear of queue equal to size of queue -1. Rear of queue is -1 equal to 10 minus 1, that is 9. So it is false. Comes to the else part. Now rear of queue is incremented. So rear of queue equal to 0. Then queue underscore pointer of rear of queue. So rear of queue is 0. So 0 is here. So queue underscore pointer of 0 equal to insert the data. So insert data is 10. So 10 is inserted. You can see. Now again comes out of the enqueue function. Now again enqueue with the data 13. So data 13, we have rear of queue equal to 9 is false. So rear of queue is 0. Then we have because that indicates the queue is full. Right now the queue is not full, just there is only one item. So comes to the else part. We are incrementing the rear of queue by 0 to 1. Then we have queue pointer of 1 equal to inserted data. So 13 is inserted. So to the location 1, so index. Please follow the convention: queue data, index, and address. So at the bottom we have address. Then we have index here, and the data is stored in this part. So index right now rear of queue is incremented to 1. So that's why you access this index. Okay. Then you come out of the enqueue function. Then we have enqueuing data 22. So again rear of queue equal to size of queue -1, that is 10 minus 1, 9. So that is false. Comes to the else part. So rear of q is again incremented to 2. Now q pointer of 2 is data 22. So 22 is inserted, comes out of the enqueue function. So deleted item, now it will dequeue the item, goes to dequeue function. So deleted item equal to -1 right now. Front of q equal to rear of q. So front of q is -1 equal to rear of q. No, it is not. So it becomes false. Comes to the that indicates if both were equal, right? That indicates that the q is empty. If both front of q and rear of q have come together, that means the q is empty. So if both are split, that means there is some data. Okay, so it comes to the else part. It increments the front of q. So front of q is now incremented. Now deleted item is q pointer of front of q. So the front of q is first accessed, and the dequeue of the first. So remember, q is a first in first out. This was the first data which was added, so it has been removed first. This is the second, it will be removed second. This is the third is removed third time. So that is first in first out implementation. So deleted item is been we have accessed the deleted item, that is 10. It returns the deleted item. So deleted item 10 has been written. Next again we dequeue, it goes to the dequeue function. Deleted item now is -1. Okay, we have front of q equal to rear of q. So 2 equal to 0, false. Comes to the else part. Front of q has been incremented to 1. Deleted item now equal to 13. So deleted item, we access the q pointer of 1 because front of q is 1. So you access this. So this now it is turned into, so it's a naming convention. The data, so the front of q will be kept on incrementing. This data is turned garbage. Inside the computer it actually still remains 13. So the data will be 13 because the location we are calling it as garbage, because right now once the item is deleted from the queue, that 13 is a garbage for us. So because we have dequeued the element from the queue, so it is no longer a valid data because we have implemented, according to the convention, we have implemented a dequeue. So no longer that data is valid. Okay, so deleted item is 13. It returns the deleted item. So it goes, you can see deleted item has been printed. Then again we dequeue, call the dequeue function. So it goes to dequeue. Now deleted item is presently -1. It checks front of q 1 equal to 2, false. Comes to the else part. Again front of q is incremented to 2. Now deleted item equal to q pointer of 2. Q pointer of 2 is 22. So 22, deleted item is 22. It returns the deleted item. So deleted item 22 is printed. Now again deleted item, we call again the dequeue, goes to the dequeue function. Deleted item is -1. Now in this case, front of q equal to rear of q, both are equal. So it is true, which means q is empty. There is no valid data available. So it prints q empty. Then it returns deleted item as -1. So -1. It's not a valid deleted item. Okay. From there it returns 0. Okay. The time complexity of this algorithm is 1 because it is sequential. All are sequential steps. So you access the data once, you put the data, and you remove the data once. So it's all single sequence steps. And okay, so if you want to access the code of this algorithm, you can click on the code button in the Robominions.in AI interview preparation app. To download this app, visit the website robominions.in and click on download latest version. You can download for Windows OS and click on download anyway. Okay. Signing up, Dhananjai Sharma,
founder of Robominions.in. Don't forget to subscribe to the YouTube channel, share with your friends and family. Visit Robominions.in website, crack your toughest coding questions and tech interviews by downloading latest version of the app, and make your coding easy. Thank you for watching this video. Bye.